Whole winter melons enter the controlled receiving area, where traceability starts before any product touches the process line. Staging keeps inbound material organized and prevents uncontrolled movement into hygiene-sensitive zones.
FIFO sequencing reduces residence time and keeps raw material condition more uniform at the wash feed.
Alignment ensures controlled transfer into the wash system without dropping or bruising the produce.
Gentle tipping transfers product into the line while minimizing impact damage before washing.
Metered feed prevents pileups and gives the wash section enough spacing to clean each unit effectively. Removing loose contamination before the flume reduces wash load and improves sanitation efficiency. Flume loosens soil across the rind while cushioning heavy produce during the first wash contact. Controlled agitation loosens soil before spray rinsing, improving cleaning while avoiding unnecessary mechanical damage. Controlled outfeed lets loosened soil and bulk water leave the product before targeted spray rinsing.
Spray rinsing removes suspended soil, so the sanitizer stage can act on a cleaner fruit surface.
Winter melon rind can tolerate gentle brushing, which removes stubborn soil lodged in surface texture.
Mechanical action removes persistent contamination that flume and spray rinsing alone may leave behind.
Controlled discharge prevents resoiling and keeps the cleaned product moving steadily into the sanitizer section.
Controlled dosing keeps antimicrobial concentration within the validated operating range for produce washing. Recording the active wash conditions links hygiene control directly to the lot being processed.
Brief draining reduces carryover, so the final rinse can remove residual sanitizer effectively.
Final rinsing clears residual chemistry while preserving the cleaned product surface for inspection.
Removing surface water improves downstream visual inspection and limits uncontrolled dilution of cut surfaces later. Verifying rind cleanliness here reduces the risk of carrying contamination into the cutting zone.
Returning the representative unit at a controlled point maintains lot integrity and avoids unnecessary handling. A controlled transfer separates the wet wash zone from the cleaner cutting area and supports good hygiene design.
Even spacing improves manual checks and prepares the product for controlled trimming and opening. Correct recipe settings help the sorter flag abnormal units without rejecting acceptable product unnecessarily.
Optical inspection adds consistent screening for color, size, and visible surface defects before manual opening. Automatic rejection removes visible outliers before they enter the labor-intensive cutting section.
Manual trim handles defects and stem remnants that automated systems cannot always remove cleanly. Accurate alignment is needed so the melon opens cleanly and exposes the seed cavity for removal.
Splitting exposes the internal cavity, so seeds and soft core can be removed before flesh preparation. Presenting the halves open side up lets operators remove seeds cleanly before further size reduction. Seed removal improves downstream texture and keeps unwanted hard particles out of the puree line.
Peeling separates the tough outer rind from the edible flesh, so the puree line receives a more uniform input.
This visible split locks the two roots. Edible flesh continues toward puree, while clean rind enters the fiber powder byproduct line. Once rind is removed, the edible flesh continues on the sanitary main route toward controlled size reduction.
Clear byproduct identification prevents cross-mixing and preserves traceability outside the food contact puree stream. Uniform size reduction improves grinder loading and makes downstream pulping more consistent. Large cubes feed the grinder more evenly than irregular halves and help stabilize throughput.
A quick visual check after cutting catches any remaining non-uniform pieces before grinding.
In, diced winter melon flesh with one foreign rind fragment removed, out cut, clean diced flesh
A short buffer smooths the feed rate so the grinder sees a stable product load. Metered grinder feeding prevents surges that can overload the extraction step downstream. Grinding breaks cell structure and prepares the flesh for efficient pulping and screening. A controlled pump feed keeps the mash moving without excessive shear before pulping. Gentle positive displacement pumping transfers the mash while protecting texture before screening.
The pulper begins separating soft edible material from remaining coarse particles to improve puree consistency. Controlled screening removes coarse structure while preserving the edible fraction needed for puree production.
Reject solids that do not fit the puree specification are removed here and do not return to the food stream. The balance tank stabilizes flow between pulping and fine finishing, so downstream equipment runs consistently. The finisher provides a tighter screen cut for more uniform puree texture and fewer visible particles.
Fine finishing removes remaining coarse particles so the puree base is more consistent before deaeration and heating.
A uniform puree base makes downstream blending and heat treatment more reliable.
Oversized particles leave the process here, so only specification-conforming puree continues forward.
The inline sieve provides an additional particle control step before enclosed tank handling.
This secondary screen protects downstream equipment and helps stabilize final texture.
Removing retained remnants here keeps the puree stream more uniform before deaeration.
Deaeration removes entrained air that can affect oxidation, foaming, and fill stability later. Under vacuum, dissolved and entrained gases separate from the puree more effectively than in atmospheric handling.
Lower air content helps protect color and improves the stability of later thermal processing and filling.
The buffer tank stabilizes the deaerated product before standardization and heat treatment. CIP verification confirms the cleaned circuit is free of residual chemicals before product is allowed into that section.
Normal line release prevents accidental mixing of cleaning fluids with food product during startup.
Process wastewater is treated in a separate utility system and never returns to the puree production line.
Here flotation removes suspended solids, the clarified wastewater continues to biological treatment and remains fully separate from food processing.
The rind byproduct stays on its own controlled route, where dewatering reduces load on the dryer. Mechanical dewatering reduces free moisture before thermal drying and improves byproduct handling efficiency. Even dryer loading helps produce a stable fiber ingredient, with more consistent final moisture. Drying prepares the rind for milling into a more usable fiber powder product.
Sifting and bagging complete the byproduct route while preserving clear identity separate from food puree and waste streams.
The blend tank provides controlled standardization before the product reaches the critical heat treatment step.
Standardization starts with measured data, so the blend can be adjusted within specification using permitted process controls.
Brix is adjusted here using the same fruit stream, keeping the formulation within the permitted process approach.
Uniform mixing prevents localized concentration differences before thermal processing.
Inline shear can improve texture uniformity before heating without changing the product identity. Pasteurization is the key controlled kill step, so product entry and flow must be stable and documented.
Continuous time temperature recording provides direct evidence that the critical heat treatment conditions are being met.
The diversion logic ensures only full treated product can proceed beyond the critical control point.
After the kill step, the treated puree remains in a closed sanitary path to protect its microbiological status.
Controlled cooling prepares the product for aseptic hold and filling while keeping the process fully enclosed. Independent review of the CCP record confirms the lot met the validated thermal process before aseptic filling continues.
Proper sample labeling keeps microbiological results tied to the correct production lot.
The aseptic surge tank buffers the sterile product just ahead of filling, while maintaining the closed hygienic barrier.
The selected filler program locks the pack format, so sterile transfer and target fill control stay consistent for the entire lot.
Correct drum positioning is essential, so the sterile connection can be made without compromising the product path. The sterile coupling protects the treated puree from recontamination during transfer into the drum liner. A controlled fill maintains sterile integrity and helps achieve the target net content for each drum. Immediate sealing keeps the sterile barrier intact once the target fill is reached. Loading links the packed drum back to the receiving lot, process records, and critical control documentation. Final package checks confirm net content and add an appropriate post-fill inspection step before warehousing.
Stable palletization protects the packed drums during storage and shipment, while keeping lot identity intact.
The documented handover completes a fully traceable job, from raw winter melons to aseptic puree drums with separate byproduct and waste control.